Okay, so today we're talking about graphing polynomial functions, and we're going to be doing this in two different ways. One of them is going to be using technology to help us. You've already seen me use Geometer Sketchpad to do that, kind of up on the screen like that, right, where I plugged in a function and it kind of graphs it automatically. Now with Geometer Sketchpad, though, your calculator does do some things a little bit better than Geometer Sketchpad, like finding the maximum height of these points and stuff. It takes a little bit more work with Sketchpad, but your calculator actually can do that, approximate those pretty well. So we're going to be using a graphing calculator. This is a TI-84, so you can start by turning it on, the on button on the lower left. And, well, let's see if I change, I don't know if that exposure is any better, but that'll do. So let's start by graphing a polynomial. Let's graph this following example. And I'm just going to make this up on the spot. Hopefully it's an interesting one. Yeah. Let's do x to the fourth plus 2x cubed minus 3x squared plus 8x. And then we'll do, I don't know, maybe minus 5. 5 feels good. Right, so currently you guys could probably tell me a few things about the general shape of this. Yeah, what facts do we know about this? What facts could you tell me? Right, so yeah, let's actually even write these down. So it has as many as 4 x-intercepts, right? Right? Up to, right? And we determine that based off of the exponent of the leading term. What else could you tell me? Any other facts?
The 3 bends.
Right, as many as 3 bends. And actually, I'm expecting it likely will have all 3 bends, although I think sometimes the sign alternating and different things can affect that, where some of them maybe isn't a bend, but it might look like a swoop or something like that. I don't know if that's a swoop or not. Whereas like a true bend, I would say, is kind of where it actually changed direction, right? Where this one didn't change direction, it was always going up, but still was influenced by one of these variables. Let's see, what else do we know? About y-intercept? Right, 0, -5, right? Or the y-int is -5 based off of the constant term, right? We know that. And what could you tell me about the end behavior, or what would the general shape of this possibly look like? It's going to look like a W, and how would I know that? But how do I know it's not like a letter M instead of a W? Right, because the leading term is positive and x to the fourth, so I'm expecting that the general graph might be W-ish, although any of these dips and bends on the W might not be quite that way. So in terms of end behavior, I could also say that y is approaching infinity as x approaches negative infinity, and y is approaching infinity as x approaches positive infinity. Right? So as we go to the left, it's going up, and as we go to the right, it's going up, is kind of the layman's terms of describing that. So let's talk about plugging this in a calculator here. I guess I don't have a good way to... Once I switch over to this, I might have to switch back and forth. Let's see. That's okay. Well, I'm going to have to do an initial setup on this anyway. Now, since we use these calculators in pre-calculus and other courses, the first thing I want you to do is hit the mode button. And for instance, mine is in polar form. Hit down using the arrows here and go down to func and hit enter on func. Enter is on the lower right of the calculator. Okay, so that's going to make it a function grapher versus polar form, which is what she's working on over there, where you get crazy, spirally, swirly graphs. We're not interested in spirals and swirls just yet. And let's see, I think everything else is fine here. Maybe you have it under simultaneous. You can select sequential, but that won't affect us in any way. All right, so that's just kind of the initial setup. And now what we're going to do in order to graph is there's this y equals button right here. I guess I can point to it with my finger and my mouse. How crazy is that? So I'm going to hit y equals. And this is where I'm going to edit my functions. All right, so I've got y1, y2, y3, y4. So I can actually have multiple equations all plugged into this if I wanted to graph more than one at a time. And you can hit the clear button and clear y1 and delete anything else that's in there. And then just go up to y1 for a starting function. All right. So now in y1, this is y is like my f of x or my y equals, right? So I'm going to now write my equation in here. So what was my equation? It was, let's see, it was x to the fourth plus 2x cubed. So the way we do that, the way we get an x is with this x button right here, xt theta n. This is your variable button. So there's an x, all right? So don't use the alpha and then that letter x to get, right? There's, where would that be? Yeah, down here, there's a little green x. That is not the same x that I'm referring to, okay? This is like the letter x. This is the variable x button up top here, okay? So make sure you realize that. So we've got x to the fourth. The way we can do the fourth is with a little caret. So x to the fourth. And now I guess technically in this, if I start typing plus, it's still up in the exponent. So I might just have to hit over or down just to get out of the exponent there. Depending on what mode you have this calculator in, it can do different things. And then what was it, plus 2x cubed, was it? So I do plus 2x cubed. And then minus 3x squared plus 8x. So we'll just keep going. So make sure you get out of those exponents. 3x squared plus 8x. Yeah, the delete key, yeah. Or what you do is if you use the arrows and move over something, you can kind of type over it, I believe. I think, yeah, its default mode is that it will type over a letter rather than inserting it in front of whatever letter or number you have there. And notice that since mine doesn't all fit on one line, it's got this little arrow indicator here showing that I could scroll back to the beginning. Now I didn't fully enter this yet. I still got to enter my last term. Right, and then my last thing was what, minus 5. And then regarding subtract symbols on the calculator, there's a difference between the subtract operation, which is calculating the difference between two things, versus the kind of negative symbol. All right, so those are not synonymous. Your calculator will not treat them the same, even though maybe in your mind a subtract symbol is the same as a negative symbol, but they are treated differently. So make sure that this minus 5 is in fact subtract here. All right, so we've just plugged all of that in, and what I'm going to do is hit Window, this key here, and here you can actually manually change kind of the size of the graph that we're looking at. So you can see the minimum x value, the maximum, the y min, y max. So we can actually manually change that, so I could have it start on the x-axis at like -20 if I want. And I don't really know what I want just yet, but there's also some options under the zoom button, the middle one here. So I can zoom in a box, I can zoom in, zoom out, zoom decimal, zoom square. Don't worry about those. But 6, if I hit 6, kind of like on a cell phone, it'll select that from the menu, or you can go down to Z standard, and that will do the standard viewing window, which is -1010, -1010 in all directions, which is the one that I happen to have, but I don't know if yours was on that, so that's why I'm walking us through that. So hit enter on zoom standard, and now it's thinking, and I'm seeing some stuff take place. Right? I saw something happen, but I can't quite see everything. The other way to get to this graph, besides hitting like zoom standard, is there's the actual graph button over here on the right. Okay. So I can't see everything in this current window. So what I'm going to do, it looks like I could use some more height on it, right? The vertical could show me a little bit more here. So I'm going to, I need to make a smaller y-min value so I can see where this turn is down here on the graph. And actually, I don't know if it technically swoops back or not. I'm guessing it might not. So let's go to window again, and let's change our y-min. I don't know, what do you guys think is a good y-min to try? Maybe negative 30? Maybe, I don't know. So I'm going to hit negative 30, enter, and we'll graph it and see what happens. And it's thinking, oh, I was closer that time. So I still, notice on my graph, it still doesn't show that minimum value, but I'm close. So let's try another value. I don't know, maybe I'll just try negative 50. That might be too much, but. And now I'll hit graph to go back to the graph, and it will reprocess it. There we go. Okay. And I do notice there is this slight kind of around the y-axis. You can see like there's that little bit of a swoop effect there. It won't like. Aha, syntax error. Let's see, window. Negative 50. Y equals. Aha. Here's a student's calculator that had a syntax error. It looks like there was a plus sign up there. And I think that was it. And now when I graph, I do get the same thing. So good. Thank you. Thank you. Now notice when it was graphing up in the top right, there was like this little animated line on the top right. I don't know if you spotted that. But that is basically, it's processing, it's thinking like it was in the process of graphing. So if I had like 7 graphs, you would see that animated line as it would slowly draw each one, and it would just draw all of them. The other thing, notice my y-axis is like practically a solid chunky line right now. And that's because the tick marks are marking every single unit, and I'm going from negative 50 to positive 10, and there's just not enough pixels on the screen to represent that accurately. So if I go back to window, there's this thing called y-scale, Y-S-C-L. So instead of counting by ones, I could choose to count by maybe 10s or 5s. I'll try 5s first. And I'm going to hit graph. And notice now I actually have a little bit better of a tick mark representation here. Right? Now, I could, if I wanted, I could close the margins on my x-min and x-max. It looks like I could go from maybe negative 5 to like positive 2 or something like that and fit everything if I wanted this to be a little bit broader. But now I do want to point out that this graph is no longer proportional. All right, I don't know if you've ever like watched like 4:3 ratio television on a widescreen TV and had it stretch it, and like everyone on TV's then like really wide, right? Like that's kind of what's going on here, where I've stretched this in this case vertically, but not horizontally. So this is not representative of the way the curve is, because I've changed the scale in only one dimension but not the other. All right, so it's like I've stretched this image out. But now, let's see. Let's actually check. Let me grab a snapshot of this. And I will paste this here. And let's see if this graph is representative of what we had so far. So, actually, maybe I'll even make that a little larger. So, based off of this, do I have 4 x-intercepts on this graph? No, but we didn't have to have 4. The 4 was just the maximum amount. Do I have 3 bends? Not really. There's definitely 1. And then the swoop right here does represent 2 bends, but that, I mean, isn't our typical, concept of a bend. Let's see. There's my pen. There we go. Let's see. Does the y-intercept appear to be at negative 5? Yeah, right. There's a negative 5 right there. It does appear to cross there, so we were right about that. The general shape we got, I mean, this is kind of a W-ish, right, where it's kind of like this little dip down just didn't happen as much as we thought, but that's okay. And the end behavior we got right as well. So now some things that we'd be interested in are x-intercepts. All right, so where do those x-intercepts cross? Now this graph, maybe you could say, I don't know, maybe that crosses at +1. Maybe this one crosses at 1, 2, 3, 4. Maybe it's at -4, but I'm not entirely sure. This could cross at like weird decimals or something, and I wouldn't know. So what we're going to do is use the calculator to find those more exactly. And your calculator can do that, which is nice. Let's see. So let's go back to our calculator. And the first thing I'll show you is this trace button here. And if I hit trace, now I've got like this little spider thing kind of showing on the graph. Let's see. I guess I might try to zoom in a little bit just to show things better. You might see fewer of my buttons on the calculator, but that's okay. So you see this little crosshair, and it's saying that, mine's showing r and theta. I thought I switched it out of polar form. That is really weird. Are you guys getting an XY when you hit trace down at the bottom? Okay. Hopefully you're getting the XY and not the polar form. Table set, format. Aha, there it is. There's my problem. I want rectangular, not polar. Okay, so back to graph, trace. Good, I'm glad I found it. So, good, so I got 0, -5. So it's representing a point on this graph, and you can see our equation up there. And if I use the arrow keys, left and right, you can see my little thing moves along, and it gives me the coordinates at that particular point. Right, so I can kind of trace, literally, the graph, right? Now, let's see if I could get that leftmost x-intercept. And it doesn't look like it's allowing me, right? It's kind of jumping above, jumping below, jumping above, jumping below. And the way it's working is it's kind of like jumping a set number of pixels. So I can't get it to land exactly on the x-axis. So trace is not necessarily effective for that. I mean, I could zoom in, zoom in, zoom in, zoom in, all on that point, and then use trace and get something a little bit closer. And notice if I wanted to find the minimum value, this local minimum, which I think is actually also the global minimum, I can't tell for sure. Is the minimum, it looks like it's somewhere around -35.77 or 79, but I don't know. I don't know if it's more than 79. I don't know if it actually is at the minimum height right there. So the calculator actually, besides trace, has some tools that we have that we can measure these more exactly. And above the trace button is the calc menu. So if I hit second and then calc, I can calculate some different functions on this graph, right? So I can calculate a value, which I'll show you what that is. Value is, let's say I want to figure out what is what is y when x is 8, and I'd hit enter. Actually, let me pick something that's going to be within our graph because I don't want it to shift mine. So let's say I plug in -3. I plug in -3. Apparently y is -29, and it shows me where that point occurs, right? So value will plug in an x, it'll give you the y, right? If I go to second calc, I can calculate a 0. Now, what's another word for 0? We have 3 words that work. Root is another word for it. And what's perhaps x-intercept is the most familiar one, right? The one that probably makes the most sense to us. So if I want to find an x-intercept, that's what I'm looking for. I want to find a 0. All right, so I'm going to hit enter on 2. And now it's got my little crosshair here. And it's asking me a question, left bound. So in order to find an x-intercept, what I'm going to do is I have to move to the left of where my x-intercept is. Now, in this case, you're probably more thinking of that as above and below. But the point above in this instance is, in fact, to the left slightly of this x-intercept. So I'm going to move to the left of it and hit enter. And now it's asking for a right bound. So I'm going to move to the right of it and hit enter. And what I'm doing is I'm giving it kind of like a region for it to look at, for it to search for that x-intercept. Because what if this graph had like all 4 x-intercepts and I tell it, find me an x-intercept, it's going to be like, which one? Like, I'm confused. You're asking me to do too much, right? So I have to kind of give it an area. Look between here. You got to narrow down the search. And then the last question it asks for is a guess That you can just hit enter on, it doesn't matter. But if you wanted, you could try to move it close to where you think the x-intercept is, so it could try to pick one for you. And that would be like, what if there was like 7 x-intercepts in between there, right? Between the range we gave it. Your guess would then just choose the one that was closest to your guess. So hit enter one last time, and I get this as an x-intercept, or my 0, right? And all right. Electronically speaking, that might look a little bit weird to us, but I'll explain it. But it says 0 is negative 3.574725, and then what is going on with that y value here? Does anyone know what that means? Oh, east, yes. Yeah, that would make sense. Does anyone know what this capital E represents on calculators? No. It actually represents scientific notation. So what this is saying is, this is the y value is negative 0 point, and then I've got 12 total zeros, so 11 zeros after the decimal point, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then a 6. So that E is representing scientific notation, where the exponent is negative 12. So in calculator speak, I think we could call that 0. That's close. That's pretty close to 0. Right? As far as we're concerned, that's 0. So our x-intercept is actually going to be at x equals negative 3.57, we'll say. All right. So sometimes it will your calculator will actually give you a 0 there for y, but it doesn't always. So don't be confused if it gives you some crazy e to the negative representation. So let's have you guys using the same technique. Well, actually, no. Before I show you this other x-intercept, I'm going to have you find that in a moment. Let's talk about how we could find this minimum value, which, like I said yesterday, to do this mathematically, algebraically speaking, you can find that minimum using calculus, which we don't know, but it can be done. We're going to use our calculator to find that minimum value. So we'll do that real quick, and then I'll have you guys find the remaining x-intercept. So to find that, I'm going to go to second calc, and I'm guessing you could figure out which one you'd want to use to find that bend in the graph. Probably minimum would be good, right? So if I go down to minimum, we'll find a local min for us. And once again, it's going to ask the same question. So give us a point to the left of the minimum you're looking for. So I'm going to pick a point kind of to the left of it. And you see this little triangle arrow indicating that the minimum is to that direction of that point. And now right bound, so I'll move to the right of it. And you can give yourself some generous room there, right? So now I'm saying that the minimum occurs between these two arrows. And then it's asking for a guess. And I'll say, you could just hit enter, or I'll actually move it somewhere around there. I'm guessing the minimum's maybe this negative 35.79. I don't know. And I hit enter, and I get, who knew? The minimum is actually lower than I'd originally anticipated. So that's why it's good that I got the exact measurement using or a more exact measurement. I mean, technically this is still a decimal approximation, but so my minimum is the point negative 2.45 comma negative 35 point that would be 99. So I guess I have to round that up to 3600 if I'm rounding to 2 decimals. Right, so that's where the minimum value is occurring on this graph. All right, so I'm going to take a break here from the video, and that is how to graph using a graphing calculator, and we'll have you guys find the remaining x-intercept using the graphing calculator. All right.